In this video, we are going to solve applications of systems of linear equations by graphing. Now, there are 6 steps that we see here. I'm going to walk you through some of the strategies I would say will work really well for solving systems of linear equations. So step 1 is to read the problem, make sure all the words and ideas are understood. Let's talk through this first example. It says Marissa is making 9 quarts of whitewash made of white paint and water for her brick fireplace. The number of quarts of paint is 2 times the number of quarts of water. How many quarts of paint and how many quarts of water will Marissa need? Okay, so we read the problem. You can see pretty clearly what we're trying to do. We're trying to figure out how much we need of paint and of water so that we can make this mixture for Marissa. So that leads us then to our second step, identify what we're looking for. And I kind of talked that through a little bit, but basically remember, we are looking for how many quarts total of paint, of water, and of whitewash to get to that 9, okay? So that is what we're looking for. So that's step 1 and 2. We've read the problem, we've identified what we're looking for. Let's move now to step 3. We're going to name what we're looking for. We're going to use some variables to represent those quantities. Usually I'm going to use some variables that maybe start with the same letter so I can keep track of things. So I'm going to call P the number of quarts of paint that I want, and I'm going to call W the number of quarts of water. So now we got to translate the words we saw here into a system of equations. So usually you're going to get 2 pieces of information. In this case, we know we want to make a total of 9 quarts, and that the relationship between the 2 of them is that the number of quarts of paint is 2 times the number of quarts of water. So that gives us 2 equations. Our first equation is going to be the total. P plus W is equal to 9. The second one is about the strength of it. And it says that the number of quarts of paint, which is P, is 2 times the number of quarts of water, which is W. So that's why we get those 2 there. Okay. Now, the next step is for us to solve the systems of equation using good algebra techniques. Now, in this particular video, we are going to use graphing to solve it, but you can solve it by algebraic methods if you know how to use substitution or elimination. Those might be good options. Now, if we want to solve it by graphing, we want to look at our first equation, P plus W equals 9. Now, I have rearranged it because actually I've kind of gone in alphabetical order. My P's are going to be along my x-axis. My W's are going to be along my y-axis. So this is kind of like an equation you would think of in slope-intercept form, y equals mx plus b. We would have a slope would be on our P, -1, and our y-intercept would be 9, which would be the 0.09 is where we start. So we're going to start at 9 on our y-axis. We're going to go down 1 over 1, down 1 over 1, down 1 over 1, and we're going to create that line. So that's what you see there. Now our second line, I'm going to make this one in blue. I'm treating W like you would a Y. So I want to solve for W. So that means I have to divide both sides by 2, or I get that W is 1/2 P. Now that is an equation with slope of 1/2 and y-intercept of 0. So I'm going to start at 0. I'm going to count up 1 over 2, up 1 over 2, up 1 over 2. And I'm really concerned about where they hit each other. So once I have that blue line on there, again, up 1 over 2, up 1 over 2, then I need to know what's that point of intersection. That's going to be the answer that I'm looking for. So that 6,3 is really, really important. Okay. So now that we've solved it, we have that answer. Let me go back here, see how we've written. I like to write it as a point. That PW is our point 6,3. The P is 6, the W is 3. The paint is 6, the W is 3 quarts. So we've got that point, and then we need to kind of verify the answer. Does it make sense with our problem? Does it apply to the example they were asking? Did we answer all the questions? Well, it appears as if we want 6 quarts of paint and 3 quarts of water. Now, let's think about what we know. It has to total 9, it does, check. It has to, the paint has to be double the amount of water, check. So all those things have come into play. So that's a really good way to think about it. Did it really answer the question that we were given? In a case it did. We just found that 0.63 by looking at the intersection of the two lines. Now, if P and W confuse you, feel free to use X and Y. You can. And just, if X would have been our amount of paint and Y would have been our amount of water, you could do your equation like that without a problem. So that's a little bit about solving applications of systems of linear equations by graphing. I hope you understand that a little better now. Have a good day.